Welcome to the second session of Disruptive Innovations in the Offshore Energy Sector. My name is Benjamin Lehner. I'm the CEO of the Dutch Marine Energy Center and the coordinator of the EU's CORS project, a Horizon 2020 Green Deal project. Today, I'm absolutely delighted to have with me the founder and CEO of Oceans of Energy, Allard van Hoeken. Allard founded Oceans of Energy and made it to one of the, or even the leading offshore solar company in the world. Welcome here, Allard.
Thank you very much. It's fantastic to be here. And indeed, this is the week we are celebrating our entering of our 9th year of existence. So this Friday we have a big party with all our employees to celebrate that we've been around for more than 8 years now. So yeah, it's fantastic to be here, and thanks a lot for hosting.
That's amazing news. So you're here or you have founded this company almost 9 years ago. One big part to celebrate.
Yeah.
A second big part to celebrate is the recent news that you have started the first international installation. You have started, and not just the first international installation, but the first installation of offshore solar, which is grid connected and at megawatt scale. What was the drive? What did you bring you to this moment?
Yeah, indeed. Yeah, it's exactly this week. We're now on Wednesday, and this Monday we made the installation of the complete offshore solar farm system into the water in Belgium. So this is our first international operation. It means new governments, new rules and regulations. So there was a lot for us to learn, new logistics. And I would say after those first 4 years in our company, we spent a lot of time in designing, engineering, simulating, tank testing. Then building. Then we spent 4 years operating at sea. So during 4 years, we have put our systems in the sea. We've learned from the actual impact from the waves.
And that was here in the Netherlands that you, yeah.
Indeed, you guys had a fantastic view of our systems going out and sometimes coming back, because that was really the game, learning from the reality and making sure that everything we detect and that we could not find out from calculations or simulations, not even from tank testing, from model testing, that the reality actually brought us the biggest learning. So those 4 years have been amazing for us. So by now our team is really experienced in installing, operating, inspecting, decommissioning of the farm. So that was, let's say, another 4 years. And now we're entering the next phase of international operations. Offshore solar is, of course, a huge opportunity for almost half of the world's population lives near the coast. In all these areas, we'll have problems with space, people living there, space needed for agriculture, for buildings, for industry, for home, for roads, and then suddenly also a renewable energy comes around the corner. There's just not enough space. Maybe by now we think there's still space because there is on rooftops and so on, but we're only in a few percentage of the total energy being generated from renewables. If we go to 100%, there's just not enough space. Then offshore solar for half of the world population gives a huge opportunity to have renewable energy generated, abundance of clean energy, without the issues of land conflict, of land usage. So this is our one of our biggest drives.
And also I think you already mentioned now that providing electricity and energy to so many people, there is a huge impact you can make. So is that why you started this company? Is that where the impact you want to achieve with it?
Yes, indeed. Yeah. I spent all my life in offshore oil and gas, basically companies and operations. So for me, I'm a maritime person. I love sailing. I love being out on the sea. And for me, this is the area I want to be active in. But I also wanted to be active in clean energy.
Yeah.
So I spent some years developing tidal systems. We installed the first grid-connected tidal system in the world, or basically in Texel, floating system. And from that learning of my skill set in offshore operations, I founded Oceans of Energy, and then looked at offshore solar. At that time, offshore solar was not a topic. Nobody looked at it. It just didn't exist. And everybody said it's crazy to put solar panels out on the sea. They will not survive. So it was an exciting idea to start it. There was one little research done in the Mediterranean of one little raft with some solar panels. That was really all we could find about offshore solar. And I had this idea about how to do it. basically it had to be something very much scalable, very simple, very modular, and something that could go to a minimum of material usage. So from there I said, then it can only be that it floats right on the sea, on the water surface, because then you use the water surface as part of the structure, the reinforcement.
Yeah.
Technically saying its own weight, the own weight of the structure is carried by the water. So after that you only need to worry about the dynamic loads.
So you designed it really with the ocean in mind, based on all your experience as an offshore engineer, as an offshore project manager. You really had brought all of that knowledge together, looked at the ocean and made the perfect design for that. Was that the path where you went there?
Yes, I would say so. And also I learned from the wind industry. I was not active myself, but I listened a lot to presentations. And one remark struck me. It's somebody who said, offshore wind is not about offshore, it's about construction.
Yeah.
And I thought that's interesting. That was a new piece of information for me. So I also designed our system based on construction, on fabrication, logistics. That was also a part. So not just the offshore bit, because as an offshore engineer, you would build above the sea. You would do just what all the offshore engineering does, is build a platform away from the waves. And then, you're safe from the waves. This is what all the oil and gas platforms do. And I think that's a perfect solution for a single point, let's say an oil and gas platform or a transformator station. But if you look at solar is a surface game. You need to cover a large surface in order to capture the solar energy. Now, if you go to large surfaces, then you have that's another requirements, and you need to be able to spread out the solar with the minimum use of materials. So this is where I came back to what I just described. We call it a water lily. It's like a water lily on the sea. And as I said, its own weight, it's taken by the water, but then the dynamic loads. So they are huge. The storms, the waves, huge. You are here right at the seafront, so you know what they look like.
We see it.
And so this was this next stage. So the other analogy in our system is that it's like a human spine, if you like, where you have rigid modules and flexible modules. And together, with all these rigid and flexible, you can form a nice curvature, like we can do with our back. And our system does exactly the same. We need the rigidness to harbor standard solar panels, close to standard, but the rigid solar panels, they have the highest capacity, the highest effectiveness. And so to use those, but also to accommodate the waves. So that's our system is like a two-dimensional spine, if you like, with rigid and flexible. And together we can follow all the curvatures of the sea.
So you really took the nature as a basically inspiration for your design.
Absolutely.
That's amazing. And I mean, also we're here today, of course, because this new installation is part of a project, the EU's Course project.
Yeah.
So I'm, as the coordinator, also super curious, how did this project help you? How did this funding of the European Commission help you achieve your milestones? What were the steps there?
Yeah, so the project consists of a really nice group of partners. Yourself, very active and supporting us, so thank you very much for that. Others like RWE, the energy company, is one of the partners and observers and following closely what we're doing in offshore solar. Of course, they're interested in installing offshore solar in their wind parks. Other important partner is of course PON, West Vlaanderen, who take care of the local grid connection and the cabling. And Cinea themselves, of course, helping us. RENA, also an important partner, also with us in our follow-on project, the bamboo project, which is, by the way, another part of nature we have in our system. There's two ways to withstand violence of nature, let's say. One is the oak tree, that nature has come up with, a very big, solid tree. It resists all the storms until one day something hits it that's so big that it collapses, and then it's down. The other form of resilience is bamboo, which is very slender, actually very thin and very little material, but it also can survive all the storms. Actually, it cannot even collapse. It will survive all the storms. And our system, you can look at it also as like a bamboo system that's just very resilient and follows the waves. Also the mooring, it follows the dynamics of nature. So,
I love this nature analogies because they made it really visible what you're talking about. But with all these partners together, so we have this nice public-private partnership there. You described many of the partners, and all of that made it together made it possible to install such a large system and helped on all the different subsystems, right? So
indeed,
it's nice to have this strong collaboration and partnership there.
It's very nice and it's very important. And I think for me, that's one of the big strengths of such partnerships and the funding that the European Union is providing, and in other says the Netherlands, it's really not about the funding. It's really about setting up the partnership. And the funding is kind of an excuse to start saying, let's work together, and you get people a little bit more enthusiastic. And in the end, it's also very important, the funding. But actually, there's a long period of the project where you form the partnership and you start discussing what are your strengths, what are their strengths, how can we put all this together. And this, for me, is the real power of those funding, those programs.
So we bring together all the excellence of all over Europe to make this happen, to make this new offshore solar plants reality. So there's only one question remaining for me now in this context. What is up for the future? What do you plan inside of EU's course now? What do you plan for Ocean of Energy? Besides, of course, delivering electricity to half the world population, but what are the next steps?
It's a good question. Actually, everything we do, so everything we did here at Scheveningen, everything we're doing now in Belgium, the EU's course project, the follow-up projects, they're all focused on one major objective. And this is a fully standardized square kilometer offshore solar farm, where everything is standardized within that farm.
Square kilometer, wow.
A square kilometer, so 1,000 by 1,000 meters. It fits very royally, let's say, between 4 offshore turbines, because the distance of offshore turbines is 1.5 kilometers, going towards 2 kilometers sometimes. So you can fit that square within 4 offshore turbines. But even, offshore wind turbines, but even if there's no wind energy there, if we have standalone systems like the Mediterranean, we will still use square kilometers because everything is standardized. All the connections, all the systems, the sequence, how many of this type of floater, how many of this type of floater, the power takeoff, the grid connection, the cable connection, everything is standardized within a square kilometer. Even more, the whole logistical part is standardized. The whole port assembly, what we just did in Belgium, the whole testing, import, the commissioning, everything is standardized. Even more, the factory that goes before it is also standardized. So we're developing a standard factory for a square kilometer of offshore solar per year. This is our next factory size. So everything about square kilometers, about 200 megawatt peaks in a couple of years, this is really our aim. And then EU's course is of course a very important step. It's going to be grid connected system, it's megawatt scale, and it's international operations as I mentioned. So they have, and it's with very good partners. And other project we do is with Shell and Eneco. It's the Hollandse Kust Noord project, HKN1, where we install that will be, I'm sure this will be the worldwide first grid connected offshore wind, offshore solar and hydrogen generation combination. So that's what we're already started production now, and we're going to install that next year. That's still small because it's the first time you have wind and solar really operating in one field. But even that, it's all aimed towards that fully standardized format. And also coming back to where we started, if we looked at the operations we did in Belgium, so last Monday, that was really exciting for us. Until now, we've done everything here. Scheveningen is closer by, so you can take your logistics a little bit more relaxed. But now it's a 4-hour drive, so it's really a distance. And we looked at this and we saw the power of our system. And this is that we just installed an offshore installation in half a day. And how did that happen? Because it's all modular, it's standard, it's very simple. There were no complex tasks for the people on the ground. We have only 2 types of components. One is the floaters, they're all standardized. So we have PV floaters, also the cable connection floaters, mooring connection floaters, everything, but it's all the same floater. And then the interconnectors. So our team put together those 2 components. There was no measuring, there was no, does this component fit? Oh no, it's the wrong length, we have to go back to the factory. There's no complex thinking needed. It's just very straightforward, just put them in the water, connect them, put them in the water, connect them. And we installed one floater every 10 minutes.
Wow.
I'm sure in a couple of years from now, we laugh about that number. It will be 10 floaters in 1 minute. But still, this was such a speed and such a cleanliness of the operation. So we were witnessing there, and in a couple of hours, it was all ready. This is the installation that's going offshore. Now, that's not happening in offshore technology. It's not happening in wind. It's not happening in oil and gas. a lot of other offshore solar concepts, they spend much more time on the quayside putting their things together. So this is something we're really proud of, and I think standardization is one of the solar strengths. And in offshore solar, I think it's revolutionary how much we are standardizing and what that means for scale. Because the other thing about offshore is that you can really have some room for some scale.
Yeah.
Square kilometer is an example. It sounds so big on land. You will not be able to get any square kilometers on land anymore. But on the sea, there is a lot of space. There is a lot of space.
And we will use the space.
We often say maybe one megawatt is more economical on land than to put on the sea, because on the sea we have additional structures. But 1,000 megawatt is actually cheaper on the sea than 1,000 times 1 megawatt on the land. So actually at sea, the scale makes it more economical over time.
So you standardize, you scale,
yes.
And you, with all of that, achieve big numbers, gigawatt scale demonstrations or installations. Yeah. You achieve a square kilometer of solar floaters, and much more to really deliver energy and electricity to all the people living on the coast.
Indeed, clean energy, and also maybe one thing to mention now, I talk about this size, this scale, that people start worrying, okay, how much of the sea space is going to be covered by solar panels?
Yeah.
Is this going to kill our fish, or what's happening? And this is something I can say, no, it's not going to kill the fish. And actually, those numbers may look big, but in the end, it's going to be very small. So we think that in the Netherlands, only 1% of the Dutch part of the North Sea will be used with offshore solar. 1%. This is a very low number. The entire North Sea is 10 times bigger than the Dutch, so it's even a tenth of a percent if you look at the whole scale of the sea. So 1% covered with offshore solar panels. This means 99% is still open and wide and will catch all the sunlight and will be not having any solar panels. But even more, that 1% that's filled with offshore solar panels will be the nursery homes of our fish, of our lobsters, of our food chain. Because in those solar panels, underneath the solar panels, there is safe space for all of these creatures. And we know, everybody knows, all the biologists know, if you put something floating on the sea, it's going to attract growth. So it's attracting life. Those square kilometers will be attracting life, will be safe havens for our fish, and it will mean that actually the entire biodiversity of the North Sea will increase. This is our aim.
You also studied that quite a bit in the first demonstrations, right? There were a lot of publications around this topic with research institutes here.
Indeed, and we continue to do so, because everything I say needs to be proven, needs to be monitored, and this is what we're doing, also with fantastic partners. So indeed, it's not just about the clean energy and the people, it's also about the nature and the sea that we want to be responsible for.
In the end, bringing all of it together. So this was our second interview series. I'm very happy that you made the time to talk to me today about Oceans of Energy and the great plans. If there's anything else you want to share, feel free. Otherwise, it was very nice having you.
Yes, indeed. No, thank you very much for being here, and thanks for all the work we're doing together. And let's hope, and we're sure we do, that we will make this a big success altogether. Thank you very much.
That sounds great. See you next time.